Hello friends, in this session I'll take up some questions from GATE 2005 and GATE 2004 of Tuple Relational Calculus. Let's see those questions. So it says that let R be a relational instance with schema R equals to this ABCD. We define R1 equals to projection of attributes A, B and C on R, right? And R2 is a projection of A and D on R. Then what they say is let S equals to R1 star R2, where star denotes a natural join. Given that the decomposition of R into R1 and R2 is lossy, which one of the following is true? Now, one of the very important things of a lossy decomposition is when a decomposition is lossy, it results in some loss of information, which actually means that when you join it again, it results in some extra tuples, because there is a loss of some information, or there is a loss of some basic you can say integrity, data integrity as well. So how is it loss of data integrity? Because now when you join it again, when you take the natural join again, you get some false tuples as well, which never used to exist, right? So therefore now what they ask is over here is that if I compare this R, which is a natural join, this S, which is a natural join over these decomposed tables, and this R, what will be the relationship? Now this is very simple, that this will contain some extra tuples. So that means this R will be now a subset of your S. So R will be a subset, and what kind of subset? It will always be a proper subset, because it will contain at least one extra tuple, because it is given that this is a lossy decomposition. So our answer is straight away this C part. R is a subset of S. So answer is C. Let's move on to another question of GATE 2004. Over here we have, so this is a very important question. It also repeated in GATE 2012, I guess. So I have posted that question earlier, but I thought of posting this one as well. So this question is let R1 A, B, C, where A is the primary key, and R2 D, E, where D is the primary key, be two relational schemas where primary key is shown as the underlined one, and let C be a foreign key in R1 referring to R2. Now C is a foreign key, right, in R1 referring to R2. That means now what is the property between a foreign key and a primary key? This foreign key over here, it has values which can be all the set of values present over here, but they can also be lesser than this. So what I mean to say is this C will always be a subset of this D. Now you know that if D is also a subset of C, C and D tend to be equal, but it is not always necessary that D is also a subset of C, but C is always a subset of D. The foreign key present over here will always be the subset of the primary key present over here. So that means now what the state is, suppose there is no violation of the above referential integrity constraint in the corresponding integrity constraint in the corresponding, this is an extra thing, sorry about this, in the corresponding relational instance R1 and R2, which one of the following relational algebra expression would necessarily produce an empty relation? Now already stated over here that C will always be a subset of D. So now that means C is something lesser than or something equal to D. So what if I just subtract D from C? What I'm trying to say is, let's say C is this and D is this. So now this entire thing is common over here. So if I subtract D from C, this entire thing will get subtracted. So I'll be left with nothing, right? So that means this will always produce an empty set. So the answer is B in this case, but you also had some other options like A, C and D. If you see about A, and you think about A as the answer, it will be false because D may contain some extra values. Since it is a primary key, it may contain some extra values which are not present in C. And similarly, you can look for the other options, but this is very clear enough that the answer will be B over here. So that's all for this session. I am going to post a lot of questions on DMA numericals as well, so you can please view them as well if you are having some problems in them or you're practicing those questions. So in case you have any other doubts or you want me to discuss some other topics, you can please post them as comments in the comment section below. That's all for this session, and I'll see you all in the next sessions. Till then, stay tuned for more good work coming up. Thank you.